An airplane is at an elevation of 18,000 feet when it begins descending to the airport. Its angle of descent is 4 degrees, and if that's the case, what is the ground distance in miles from the plane to the airport? This is a problem that can be modeled as a right triangle and requires trigonometry to be solved. Let's solve it. When solving problems using right triangle trigonometry and in mathematics in general, it's often useful to begin by drawing a diagram. And in this case, this problem can be represented with a right triangle. One of the legs of the right triangle is the elevation of the plane, which has been given as 18,000 feet. We've also been given some information about the plane's angle of descent. And in this case, the angle of descent is given to be 4 degrees. Angle of descent is the angle that's showing up on the screen right now. This is the angle of descent of the airplane. It's said to be 4 degrees. So that means the angle in our triangle, the angle in our right triangle, at the top of the diagram is not 4 degrees. It would be 90 minus 4, or 86 degrees. 86 degrees. And in this diagram, these are the only two pieces of given information. The length of one of the legs, the measure of one of the angles, and I've set this problem up as a right triangle, so I actually know a second angle in this right triangle. And the question is, what is the ground distance in miles from the plane to the airport? And that distance is the distance that I'm going to label with a letter D for distance. That's the part of the triangle that I want to know. That's the part that answers the question, what is the ground distance in miles from the plane to the airport? This will require trigonometry. We'll do that next. Now that our diagram is complete, we can find the value of D. When you have a right triangle and you know, in addition to the right angle, the measure of one of the acute angles and the length of one of the sides, you can find all of the other pieces of the triangle. You can find the lengths of the other two legs, the measure of the additional angle. In this case, I only need to find the length of the other leg. And with respect to the 86 degree angle, with respect to the angle that's measuring 86 degrees, that side that I've labeled with a D is the opposite side. It is the side opposite to the 86 degree angle. The side that was given information, 18,000 feet, is adjacent to the 86 degree angle. And the side that's across from the right angle is the hypotenuse. Now, I don't know the measure of the hypotenuse, and actually it's not important in this problem, but I do know the adjacent side, and I want to find the opposite side. In right triangle trigonometry, there is a trig function that relates the opposite and the adjacent side, and that's the tangent. The tangent of any of the two acute angles in a right triangle is equal to the length of the opposite side over the length of the adjacent side. And in this case, I know that angle, 86 degrees in this case, and I know the adjacent side, and I'm trying to find the opposite side. So this will give me an equation with only one unknown. Theta is 86. The length of the adjacent side is 18,000, and I just have to find the length of the opposite side, D. So I'll take this equation and I'll solve for D by first multiplying both sides of the equation by 18,000. And that would result in 18,000 times the tangent of 86 equals the D. And now the tangent of 86, like most tangents, is going to be irrational. But when I take the tangent of 86 multiplied by 18,000, that gives me a value of D. I'll round it off to two decimal places, 257,411.99 feet is the ground distance from this plane to the airport. Now the question wanted me to answer this question in miles, so I'll take my 257,411.99, I'll divide it by 5,280, the number of feet in a mile, and I'm going to round that off to the nearest mile, and I'll be able to say that the distance, the ground distance, from the plane's location to the airport is about 49 miles.